Hey, Mr. Bells again here. This is the Data A final exam review video for 2022. This is the part one section from the sheet that we got a few days ago. So hopefully this will be beneficial. It should look like this. I'm going to go through some of these things. On this one here, I know it says solve analytically. However, it's going to be a calculator-based one, and this one was kind of off in terms of the problems. So what you would do if you were just going to solve algebraically is plus 11 and plus 11, and I get 2 to the 3x minus 1 equals 10. I'm going to log both sides. And then I can use the log-ride law, which drops that right down. I get 3x minus 1. Log of 2, that's kind of in parentheses, so it's all grouped, equals the log of 10. I'm going to divide by log 2 on both sides, and then I'm going to go right here, and you can see on my calculator, here we go, I'm going to do log of 10, close parentheses, divided by log of 2, close parentheses. Looks like that. And then I've got 3x minus 1, so I'm going to add 1 to move the 1 over, and then I'm going to divide by 3, and I get x equals 1.44. So x equals 1.44. Now, that's just an approximation, but I'm going to go ahead and store that as x, as we've done many, many times. And then I'm going to go ahead and type in my original problem, 2 raised to the 3x minus 1, just like that. And then down arrow, or right arrow over, and then minus 11. And you can see that it equals negative 1, and that's what we wanted it to equal. When I go ahead and do this one right here, this 2 is going to go up, and I'm going to get the log of 16, log of x over 16, because that's a subtraction sign, so that means division. Base 5 equals 3, so then I'll have 5 to the third power equals x over 16, because I start with my base, 5 to that power equals that expression, right? And then I get 125 equals x over 16, and x equals 2,000. And that's what that one would look like. On these ones, deciding whether it's exponential growth or decay, and what's the growth or decay percent. So I look right here, I look at the base, and if it's greater than 1, then it's growth. So this is growth. And then it's how much it is above or below 100%. So this is 8% growth. On this one right here, you can see that that's below 1. So that's decay. And we're going to say if this is 0.29, that's 0.71 below, or 71% decay. On this one right here, this is e raised to the 0.03. So I'm going to go ahead here on my thing, and I'm going to go second e to the 0.03. And I hit enter, and I get that. Definitely growth again, because e is greater than 1. However, it should only be 3.045% growth, 3.045%. And that's simply the number that it is beyond 1. So if I take that number away, then we're good. Write the equation for the table in 6. So really this is just checking, do you know how to use your stats in your calculator? So I'm going to go ahead and go here. I'm going to go stat, I'm going to go edit. If I want to clear all this stuff off, I can do second plus sign number 4, clear all lists, then poof, stat, edit. You can see all the data's gone. So 0, enter, 3, enter, 6, enter, 9, enter, 12, enter, and then I'm going to go over here to the L2, and we get 80, enter, 40, enter, 20, enter, 10, enter, and 5, enter. Now I can kind of look at this and see that the x's are going up by the same amount, and the y's are getting halved each time. So this is definitely an exponential decay type function. So I'm going to go stat calc, and I'm going to choose exponential regression. I'm going to go ahead and store that regression equation, vars, y vars function, y1, hit calculate, and you can see that my equation would be y equals 80 times 0.7937 raised to the x, even has an r value of -1, which is perfect, right? Now, again, there could be questions where it says, hey, given an x, find a y, given a y, find an x. So if it said something like x equals 10, what's y? You'd simply go to your table setup and start it at 10. And then you go, oh, 7.937. Yay. And that would make sense. 10 should give you something between 10 and 5, as it does right here. Then if we did it the other way around, we said, hey, what about y equal 200 or something like that? So I come over here and I go put in y equals 200. And for my window, I'm going to go from -15 to 15 and -50 to 500. And I think that should give me that intersection point. And you can see second trace, number 5, enter, enter, enter. That I get -3.965, which makes sense, because if y is 200, then x would have to be negative to get it to go back up that far. Okay, so those are the types of questions that we'll deal with the stats. This one says Juan has the option of saving $2,000 into one of two accounts. Account A compounds annually with an annual interest rate of 4%. Account B compounds monthly with an interest rate of 3%. Write a function for each and give the amount after 10 years in each. So amount equals 2,000 times 1 plus 0.04 raised to the 10th. That's situation A. Situation B, that would be 2,000 parentheses 1 plus, this is compounds monthly, 1 plus 0.03 divided by 12 raised to the 12 times 10. That would be that situation. We can do both these on our calculator here. So I'm going to even do this on my home screen because there's nothing I need to graph for this. 2,000 parentheses 1 plus 0.04 close parentheses raised to the 10th, $2,960.48 or 49 cents if I round up. 2,000 parentheses 1 plus 0.03 divided by 12, close parentheses raised to the 12 times 10. Remember, older calculator people put that in parentheses to make sure that it's all up there. And I get $2,698.70, and those are the two numbers. 2,960.49, 2,960.49, and 2,698.71 if we round those up. Graph the following include important information. You can just sketch the graphs, or you can do them on your calculators. Basically, they want you to know that this is a vertical shift of 5. This is a horizontal shift 3 to the left. That 2 as a base means that it's exponential growth, and this 4 means that it's going to be vertically stretched. Vertical stretch. Basically just checking on transformations, and if you know those transformations, same thing over here. This is a vertical shift up. It's going to lift that entire function up 4. This is going to move it 3 to the right. This is going to vertically stretch it. That's all you need to be able to do is talk about those ones, maybe sketch them on the graph, but you'll have your graphing calculator to be able to do that, so you can do that. Condense means to put all these things together, so the first thing I'm going to do is I'm going to bring these up. So I'm going to have the log base 3 of x to the 5th, because this is also addition, and that's a positive. That can go with it, so then I can make that 6x to the 5th. And then since this right here is subtraction, I can make that go downstairs. And then this simplifies to base 3 of 6 over 2 becomes 3, so 3x to the 5th. That would be the final answer for that condensing one. Okay. Page 2, we'll talk about some of the things that are on this page. It says solve analytically. So the first thing we do on this one is take this 4 and divide it over. So divide by 4 and divide by 4. Get the log of x base 3 equals 3. And then I'm going to rewrite in exponential form. So base to the power equals the number. So 3 to the 3rd equals x, and x equals 27. and be done with that one. Okay, over here, I'd go ahead and bring this up, and I'd get the log of 3 squared is 9, so log of 9x base 5 equals 2. And then I would rewrite it in exponential form. Actually, I wouldn't use that log. 5 to the second power equals this, so 5 to the second equals 9x. 25 equals 9x. Divide by 9, divide by 9. And x equals 25 ninths. And you can leave it in fraction form. This one over here, go ahead and subtract the 3 first, subtract the 3 first. For e to the x minus 1 equals 8 e to the x minus 1, x minus 1, sorry, that's one big minus sign, equals 2 when I divide by 4 on both sides. And then I'd have to natural log in this case, so I'd ln here and I'd ln there. And then that cancels out, so I would end up with the natural log of 2 plus 1, because that minus 1, this whole thing would come down, it would look like this. And then I just add 1 to the other side to cancel that off. That's where that plus 1 comes from. So it would look like that. This one says solve graphically. If I bought a new van for $25,000, depreciating rate of 20% annually, how long will it be until the van is worth only $10,000? I'm going to put $10,000 equals $25,000. 1, if it's depreciating at 20%, that's 1 minus 0.2. And that's raised to the x. I'm going to go ahead and solve that by graphically taking it. So here we go. Y equals clear. Unclear. 10,000 in there. 25,000 in there. Parentheses 1 minus 0.2. Close parentheses raised to the x. I just don't know the years. I go to my window. 0 to, it's going down 20%. That's quite a bit. I'm pretty sure it's going to happen within 10 years. And then I can put 50,000 in here. You know, it starts at 25,000. I'm just trying to see stuff. If I want to see more of my horizontal axis, I'm going to go negative 5,000. So we got graph. That's a pretty good window for what's going on. Second trace, number 5, enter, enter, enter. And I get 4.1 years. 4.1 years. This one, find the inverse of y equals 4 to the x. I'm just trying to undo this one, so if I had it like this, I'd have log of base 4 of y equals x, or we just say that because of the fact that we're going to do it in terms of y equals log base 4 of x equals y. We're going to undo those things. And you can see much clear, y equals clear and clear, and 4 raised to the x, and then math, right, is log base, which is a, and then we do 4 and x, and zoom 6. You can see that those are inverses of each other because they're reflections over the y equals x line. I know the red doesn't show that it goes all the way down, but it really does go all the way down. Okay. Use your calculator to evaluate log of 20 over 5. So you have two options. You can do log 20 over log 5, which is the change of base formula, or like we just showed here, you can use math and a, the log base, which changes it on this thing. Okay, given the table, write the exponential logarithmic regression equation. That's just stats, just like what we had before, so I'll go ahead and show it to you on here. One more time, stats edit, and here, 3 enter, 5 enter, 11 enter, 15 enter, 28 enter, 38 enter, 51 enter, L2, 8, 15, 28, 85, 180, 2, 80, and 580. So I'm going to check real quick on which one it might be, exponential or logarithmic. So let's go down here. I'm going to do exponential regression. And that says it's a 0.958. That's pretty strong. Stat calc. Go down to natural log regression, and that's your logarithmic regression. I know it says ln, but it really is the only one that the calculator uses for it. And you can see here that that's 0.829. So in this case, we're going to use exponential. That would make more sense. So stat calc and exponential regression. Vars, y vars, function, y1. So 11.285 for 11.286. Y equals 11.286, parentheses 1.0884 to the x. That's a pretty decent equation for that one. Okay, graph this, solve this, factor this. So graph, what they're looking for is just, we understand all of these things. So the vertex would be at 3, 5. Right, 3, 5, so 1, 2, 3, 1, 2, 3, 4, 5. It shows that it opens down and that it's pretty skinny, so we're going to have something that looks like that. You could check another point, or you could use your actual graphing calculator to get it to show that too. So let me just throw it in here. So y equals -4 parentheses x minus 3 close parentheses squared plus 5, zoom 6, and you can see that my window and that window, my window and that window look very close to be the same. I apologize, I just looked over to the monitor and saw that there was some sun on that before, so hopefully I'll check the rest of the time to make sure that that's good. So solve this one, 2x squared plus 8x minus 7. It doesn't say to solve any specific way, so I'm going to go ahead and just go here. 2x squared plus 8x minus 7, and then y2 make it be 0, and zoom 6. So it looks like it has two solutions, one right there and one right there. Second trace, number 5, enter, enter, enter. One of them is 0.7386, 0.7386. And the other one's right over here. Second trace, number 5. Move your cursor closer to that point. Enter, enter, enter. And then I get -4.7386. -4.7386. Okay, factoring this one. When I go to factor, I know that I have factors of 4x and 2x that'll give me 8x, or 8x and 1x that'll give me 8x. I know that factors of 15 are 1 and 15 and 3 and 5. But I know I need the difference to be a +2, and because this is a subtraction sign, I need to find a difference between these numbers. Okay? So one of the things that I would look at is I would look at multiplying one side by 4 and one side by 2. So if I do this side by 4 and this side by 2, I get a difference of 4 and 30. Well, that's 28. That's definitely not a 2. But if I do it here, I get a 12. 4 times 3 is 12, and 2 times 5 is 10. And 12 and 10 definitely differ by 2, which is what I want. So I'm going to do the 4 times the 3. 4 times the 3, that would be the outside product of my thing. And the 2 times the 5, that would be the inside product of my thing. And I need this to be plus, and I need this to be minus. So if I factored it, those are my factors. If it said solve, then I know it would be 5/4 and -3/2. And that's +5/4 and -3/2. Those are my two solutions, if it said solve. Okay, so that's what that page looks like. When I go on to this page, this one, the imaginary multiplications, we already did that on the other review, or you can look at the other review to be able to see it. This says solve the following system however you want. This includes graphing, a quick sketch of required if graphed. So we're going to go ahead and graph this one right now. So I'm going to go to on, I'm going to go y equals, I'm going to go with 3x squared minus 5x plus 1. And I know that I'm going kind of fast on this, but the nice thing about videos is you can stop it and pause it and watch it whenever you need to. 3x squared minus 5x plus 1 and 2x plus 7, 2x plus 7. I go to hit graph, and I can see there's my parabola, and it hits my line right there, and then another time that's right up there. Second trace, number 5, enter, enter, enter. I'm going to get negative 0.666, so negative 2/3, that's one solution. The other one's going to be way up here, so if I wanted to, and I wanted to see it, I could set my y max at 30. And I could see that it's right there. I don't necessarily have to do that. Second trace, number 5. Just move my cursor closer to this. Enter, enter, enter. It would have actually found it on my other screen. And that solution is 3, 13. So 3 comma 13 and negative 2/3. So if it said solve for x, but it does say solve the system, so I probably should get the actual y value back here on this one. And second trace, number 5. Enter, enter, enter. So that's 5 2/3. 5 2/3. So those are my two solutions to that system. Okay. Factoring right here, factors of 18 that add up to 9. That's pretty basic. X plus 3 and x plus 6. Again, they have to multiply together to get this number and add together. So multiply to get that number and add to get that number. Okay, here we go. Perfect square subtraction sign. So this should be 4x plus 5 times 4x minus 5. Square root of 16 is 4, so it's got to be a 4 and a 4. Square root of 25 is 5, so it's got to be a 5 and a 5. Now, because there's no x term, right? There's no x term. There's an x squared term, the constant. That means those have to cancel out. So the only way you can get that is if you have a positive 20 and a negative 20, or positive and a negative of the same thing. Over here, this one we already did, check mark. We did that on the other side. Then following data represent hours on a cell phone per day of students selected at random. Find the mean, the mode, the median, the 5-number summary, the box and whisker plot. Is there any outliers? That's all in our stats. So we can go here, we can go stat, and we can go edit. And I'm going to take all this data and I'm put it in here. So second plus sign number 4, clear all this. I don't need any of that stuff. Stat, edit. I'm going to be very careful on this as I put it in. So 4.3, enter 5.8, enter 8.1, enter 7.4, enter 6, enter 10.1, enter 2, enter 5, enter 7, enter 4, enter 7.4, enter 6, enter 7.4, enter. Now, because of the fact that I'm doing many different answers off the same data set, I'm going to go ahead and check it one more time. So 4.3, yep, 5.8, 8.1, 7.4, 6, 10.1, 2, 5, 7, 4, 7.4, 6, 7.4, nothing. That's all of them. So find the mean, stat, calc, one variable stat. I'm going to do it L1, make sure there's nothing in your frequencies. Calculate, and we can see that the mean is 6.19. 6.19. Again, that's from that right there. The mode is the number that occurs the most times. So if I look back up here, I got a 7.4, 7.4, yeah. 5.8, no. Oop, 7.4. Looks like I got 3 of them. There's nothing else that there's more than that of. The median, or the 5-number summary, I can get all that from right here. So the 5-number summary starts with a min, Q1, Q2, Q3, and a max. So median is 6, 5-number summary. Again, min was 2, Q1 4.65. Q2, which is the same thing as the median, equals 6. Q3 equals 7.4, and the max equals 10.1. So there you go. All of those numbers are there for you. Make a box and whisker plot. Easiest way to make the box and whisker plot. Go ahead and up here to your stats. That looks pretty good for you guys. So second y equals box and whisker plot on. Go here to the one with outliers, and then L1, yep, that's where our data's at. And then I'm going to go window, and I'm going to do 0 to 12, because again 10.1 was my highest. These things don't matter as long as they have some sort of gap to them. So I'm going to go 0 to 1, and I'm going to hit graph. And y equals, clear that out. And in this case, you can see that's my box and whisker plot. You would have to trace those numbers, same thing that we got from our 5-number summary, onto the line that's provided on the test. Remember, if there's an outlier, make sure you put that there. In this case, there is no outlier. So no outlier, and check, we get a box and whisker plot. The last thing that it says on here is make a bell curve and know the empirical rule. Example, mean or sample mean is 47 and the standard deviation is 3, and answer probability questions involving this. Again, you would do this, you would drop this down, you would put a 47 here, you'd go, hey, what's one standard deviation up? That'd be 50, and that'd be 53, and that'd be 56, and this would be 44, and this would be 41, and this would be 38, and we know, right? 34%, 13.5, 13.5, 2.35, 2.35, and then here through the rest is 0.15, and here through the rest is 0.15, and that's how our percentages go on that. Remember, you get an 8.5 by 11 inches sheet of paper for anything that you want to write on. Formulas, notes, anything to use for this final exam. Good luck. Good luck. And I'm going to give 3 points extra credit for the first 3 people who send me the word, let's go pink flamingo. Good deal? So if you're still listening, I'm not going to write it on the sheet, but if you're still listening and you're watching this video, send me an email with the word pink flamingo on it, and I'll get you 3 extra credit points on this final for the first 3 people that do that. See ya.